Okay, so to build off of what we started yesterday, we're going to talk about compositions today. And today's date is Tuesday, 10/27. So a composition, the word composite, it just means when a sequence of transformations take place. So sequence is the key word there. Sequence can be really one or more, usually more. So it's like multiple steps. Do this, do this, do that. That's a sequence of transformations. Anytime you see the word composite in the world outside of math, it means multiple things put together. A composite is like a puzzle of a bunch of things put together. So it could be one, but usually in this case it's going to be two. So notations. How does this look? You might remember from Algebra 1, if you had functions, when you learned the functions unit, sometimes you did composite functions and it looked like that, and you read that as f of g of x. But then there were other times where it was written like this. F of g of x, where this little tiny circle was the notation for like a multiple stepped function. And if you remember this, you always work from here outward. So you always do that one first and that one second. So you kind of work backwards when you have function notation with compositions. So the same thing would be true if I said, let's translate over 2 up 4. Let's reflect over the x-axis. If I told you to do that, let's say to triangle ABC, try to read this in reverse. Take triangle ABC, do that to it first, then after you've reflected over the x-axis, then translate it. So you're working backwards, right to left, when you have this type of notation. Sometimes it'll be written just in English. You're taking a point, you're translating it, followed by a reflection. Well, if it's written like that, obviously if this is following it, that would be the second step and that would be the first step. But if it's written in funky notation, the same words would look like this. The translation would actually be written there, and the reflection would be written there because you're working backwards with that little dot. So long story short, you start here, you do this first, then do this second. So we'll start off by just using points, not really shapes yet. So let's take -1, 4. Should be right here. Right, there's A. And the first thing we're going to do is that. We're going to translate it to the right 1 and up 2. So there would be A prime. Then we're going to take that and reflect it over the x-axis. So we're going to take this point and reflect it over the x-axis. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that would be A double prime because we did 2 steps. The key is we're going right to left. Okay? I'll erase it just so it's cleaner on my paper. I'm going to take the point -2, -5. That's point B, regular b. Then I'm going to reflect it in the line y equals x. Remember this one? Y equals x is a diagonal line right through the origin. And I go 1.5 diagonals. Half, 1. And remember, it's the perpendicular bisector. That's why I counted diagonally. So there's b prime. Then I take my green one, my new one, my b prime, and I move it to the right 2 and down 1. I happen to land right on that original line, but that's a coincidence, so that's my final answer. -3, -3. Okay, now I'll start with this one. 1, 2. It's right here. So there's point C. First, I'm going to rotate it 90 degrees. So if I used patty paper, you can look up the rule if you want. 90 degrees, and that's always positive, as counterclockwise is positive. So a rotation of 90 puts me at -2, 1. Now I'm going to take that and move it to the right 7 and up 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And that is C double prime, which looks like 5, 4. We'll hold off on this one for now. Now, when we turn to page 23, it's asking us to translate, then reflect of this triangle ABC. So if it was written in the other notation, function notation, we would translate 3, -5, then we would reflect over the y-axis. So it would look like this, because you would start with the triangle, first translate, and then reflect. So let's plot this shape first. So there's ABC, the original. The first thing I'm going to do, I'm going to do it a fancy way here. I'm going to translate 3, -5. So if I go 1, 2, 3, 1, 2, 3, 4, 5. And you would just do that individually with each point, but that's where I would now have A prime, B prime, C prime. Then I'm going to take that and reflect it over the y-axis. Here's the y-axis, so B doesn't move, it's right on the y-axis. 1, 2, 3, 4, 1, 2, 3, 4. There's C double prime. 1, 2, 3, 4, 1, 2, 3, 4. There's A double prime. It looks like a perfect little butterfly there, because it's supposed to. It's a mirror image, A prime, A double prime, B double prime, C double prime. You always want to state your coordinates when you're done, which are, there they are. Now, number 6, a rotation of 90 followed by a translation. So what that really means is we're taking triangle ABC, we're rotating it about the origin 90 degrees, then we're going to translate it 3, -5. So these words can also be written like this. Just remember, when it's written with this function notation, you start here and you work that way. So the first thing I'm going to do is rotate this 90 degrees. So put the patty paper on, or look up your rules. I'm going to rotate it the left 90. So first I trace everything. I like to write the points too, so then they'll stay there when I rotate it. When I turn it, it winds up right here. Then I'm going to take that and I'm going to translate it 3, -5. So I'm going to take each one of those points and go over 3, down 5. There's C double prime. Over 3, down 5. There's A double prime. And B, over 3, down 5. B double prime. That is my final answer after doing this, then this. So list your coordinates. What are A double prime, B double prime, and C double prime? And then the two examples on page 26 is where we're headed next. So notice that you're starting with this little segment AB. It's not even really a shape, it's just a little segment right here. First, we're going to reflect over y = 1. So first we're going to reflect over this. Then, after we've done that, we'll reflect it over that line. So let's do the orange line first. 1, 2, 1, 2. 1, 2, 3. 1, 2, 3. So there's A prime, B prime. That looks like a perfect reflection over that line. Now, we're going to ignore that. We're going to take this one and reflect it over that line. So now we're going to come up even further. And that will be your final answer. What is A double prime and B double prime? And then example 5 at the bottom, we already have a triangle plotted for us, ABC. We're going to take said triangle and first reflect it over the y-axis. So it'll end up reflecting over there. It'll end up over here somewhere, right? Then you take the one that you have over here and then you move it to the left 3 and up 5. So it'll end up probably over here somewhere. And then you write your coordinates. What are your final A, which is A double prime, B double prime, C double prime. And that in a nutshell is compositions. Just remember that you always do this first and this second when it's in the function notation.